Many people often bring up the idea of nature versus nurture when discussing the prevalence of a trait in either themselves or someone else, believing that its presence is either due to DNA or the environment in which they were raised. Scientists have two methods of evaluating this idea: twin studies and adoption studies, which also give rise to the idea of an interplay between nature and nurture. Let's take a closer look. Twin studies are especially useful for determining the influence of genetics over environment due to the two different ways twins arise. Monozygotic twins come from an early developmental split of a fertilized egg, fertilized by a single sperm. Dizygotic twins are formed when two separate eggs are fertilized by two separate sperm. Monozygotic twins share 100% of the same genes. This is because they came from the same zygote. Dizygotic twins share approximately 50% of the same genes, roughly the same amount as any other two siblings. Twins, whether monozygotic or dizygotic, are most always raised in the same environment by their parents, and both types of twins share the same uterine environment. Due to both the genetic differences between mono and dizygotic twins and the fact that they share the same formative environment, traits can be determined to either have more genetic influence or more environmental influence based on their similarities and differences.
One of the important concepts that we need to understand for twin studies is the idea of concordance, which is the percentage of twin pairs that are concordant for a trait. For example, if we say that the concordance percentage of disease X is 40% for a twin pair, it means that if one of the twin pairs has the disease, there is 40% chance that the other has disease X too. In twin studies, both monozygotic and dizygotic twin pairs share the same environmental condition. In other words, the environment is constant. Monozygotic twins share 100% of their genes, while dizygotic twins are like any other siblings that share about 50% of their genes. By comparing the concordance percentage between mono and dizygotic twins, we can better understand what plays a more important role for a disease. Does genetics play a more important role, or the environment? If monozygotic twins have a higher concordance percentage than the dizygotic twins, we can suggest that genetics plays a more important role. On the other hand, if the concordance percentage is at least equal in dizygotic twins compared to monozygotic twins, we can suggest that the environment has a more important role in having the disease. We have to be aware that high monozygotic concordance cannot alone be a good reason of the high influence of genetics, and the reason is that, as we mentioned before, monozygotic twins share the same environment.
Another method to study a specific disease, behavior, or trait is through the use of adoption studies. Through adoption studies, the trait being studied is compared through an adopted child with both their biological parents and their adoptive parents. We would expect that a trait shared between an adopted child and their biological parents would be of genetic origin, because these individuals share genes but inhabit separate environments. Conversely, we would expect that a trait shared between an adopted child and their biological parents would be under environmental influence, because these individuals share only the same environment but have no genetic similarity. Let's look at an example. Let's study schizophrenia through adoption studies. If we were to observe that a biological parent or close immediate family member, such as a grandparent, suffers from schizophrenia, and their child in an adoptive family with no history of the disease grew up to also develop schizophrenia, we could theorize that schizophrenia has a genetic basis. In contrast, if we were to see that an adopted child and one or both of their adopted parents had schizophrenia, and the child's biological parents nor any close family members did not, we would be able to hypothesize that environmental factors influence the development of schizophrenia.
Even though both twin and adoption studies can generally show whether a trait is more heavily influenced by environment or by genetics, they are not always perfect. They can be influenced by confounding factors, which are uncontrolled factors that could explain the differences. In twin studies, for example, monozygotic twins may be treated more similarly than the dizygotic twins. This would be apparent if the monozygotic twins are the same sex, when the dizygotic twins are both a boy and a girl. This would result in more varied treatment. In adoption studies, information may not be available about the genes of birth parents. In addition, the adoption agencies are specifically choosing placement of children, so the environment they grow up in could be similar to that of their biological parents. Overall, there can be some uncertainty in the results due to confounding factors in both twin and adoption studies, so it is important to realize the conclusions are relative. To recap what we have learned. In twin studies, the difference in concordance values between monozygotic and dizygotic twins can show if expression of a trait is more heavily influenced by genetics or environment. If genetics plays a larger role, concordance values will be higher in monozygotic twins than dizygotic twins. If environment plays a larger role, concordance values will be about the same in both monozygotic and dizygotic twins. In adoption studies, genetics versus environment is shown through comparing the child to their biological parents versus their adopted parents. If genetic plays a larger role, that trait will be more visible in both the biological parents and the child. If environment plays a larger role, that trait will be seen more often in the adoptive parents and the child. Overall, both of these types of studies help set up an understanding for determining the age-old question of nature versus nurture.